past is different from the future. That's the arrow of time. Unlike directions in space, all of which are created pretty much equal, the universe indisputably has a preferred direction in time. A major theme of this book is that the reason why time has a direction is because the universe evolves in a certain way. The reason why time has a direction is because the universe is full of irreversible processes, things that happen in one direction of time, but never the other. You can turn an egg into an omelet, as the classic example goes, but you can't turn an omelet into an egg. Milk disperses into coffee. Fuels undergo combustion and turn into exhaust. People are born, grow older, and die. Everywhere in nature we find sequences of events where one kind of event always happens before, and another kind after. Together, these define the arrow of time. Remarkably, a single concept underlies our understanding of irreversible processes. Something called entropy, which measures the disorderliness of an object or conglomeration of objects. Entropy has a stubborn tendency to increase, or at least stay constant as time passes. That's the famous second law of thermodynamics. And the reason why entropy wants to increase is deceptively simple. There are more ways to be disorderly than to be orderly. So, all else being equal, an orderly arrangement will naturally tend toward increasing disorder. It's not that hard to scramble the egg molecules into the form of an omelet, but delicately putting them back into the arrangement of an egg is beyond our capabilities. The traditional story that physicists tell themselves usually stops there. But there is one absolutely crucial ingredient that hasn't received enough attention. If everything in the universe evolves toward increasing disorder, it must have started out in an exquisitely ordered arrangement. This whole chain of logic, purporting to explain why you can't turn an omelet into an egg, apparently rests on a deep assumption about the very beginning of the universe. It was in a state of very low entropy, very high order. The arrow of time connects the early universe to something we experience literally every moment of our lives. It's not just breaking eggs, or other irreversible processes like mixing milk into coffee, or how an untended room tends to get messier over time. The arrow of time is the reason why time seems to flow around us, or why, if you prefer, we seem to move through time. It's why we remember the past, but not the future. It's why we evolve and metabolize and eventually die. It's why we believe in cause and effect, and is crucial to our notions of free will. And it's all because of the Big Bang. What we see isn't all there is. The mystery of the arrow of time comes down to this. Why were conditions in the early universe set up in a very particular way, in a configuration of low entropy that enabled all of the interesting and irreversible processes to come? That's the question this book sets out to address. Unfortunately, no one yet knows the right answer. But we've reached a point in the development of modern science where we have the tools to tackle the question in a serious way. Scientists and pre-scientific thinkers have always tried to understand time. In ancient Greece, the pre-Socratic philosophers Heraclitus and Parmenides staked out different positions on the nature of time. Heraclitus stressed the primacy of change, while Parmenides denied the reality of change altogether. The 19th century was the heroic era of statistical mechanics, deriving the behavior of macroscopic objects from their microscopic constituents, in which figures like Ludwig Boltzmann, James Clerk Maxwell, and Josiah Willard Gibbs worked out the meaning of entropy and its role in irreversible processes. But they didn't know about Einstein's general relativity, or about quantum mechanics, and certainly not about modern cosmology. For the first time in the history of science, we at least have a chance of putting together a sensible theory of time and the evolution of the universe. I'm going to suggest the following way out. The Big Bang was not the beginning of the universe. Cosmologists sometimes say that